Locomotives for the World. That, in brief, is the story of the North British Locomotive Company of Glasgow, Scotland. For well over 100 years, Glasgow has been noted for its engineering products, not the least of these being locomotives. Founded in 1837, originally near the River Clyde, the works of Nielsen and Company were soon too small for this rapidly growing industry. In 1903, they combined with the other Glasgow locomotive firms of Sharp Stewart and Company and Dubbs and Company to form the North British Locomotive Company, from whose three works more than 27,000 locomotives have been supplied to all parts of the world. As times moved forward, so the weight of the engines increased, from some 4.5 tons to over 180 tons. This quaint old engine shed is still standing as a link with the past. It was used by many of the earlier locomotives supplied by the company to the Glasgow and Garnkirk Railway, opened in 1831. With the passing of years, the workshops were extended and developed until the firm is now one of the largest and foremost of its kind. As well as supplying many famous locomotives to the railways of Great Britain, including the Royal Scots, engines built by the North British are in service on the railways of the world, literally from China to Peru. From the wonderful high-speed passenger locomotives to the sturdy and less glamorous freight locomotives, these engines have faithfully served the interests of transport in times of peace and war. It is indeed works employing some 5,000 hands and covering more than 60 acres that the years of experience and the skill of one generation have been passed on to the next, grandfather to father, father to son. And so the pride of locomotive building has been wedded to the modern machines and processes of the present day. So too has been preserved the skill of yesterday, now combined with the efficient organization of today. The head offices adjacent to the works are the main administration center and house the many other departments required in such a complex organization. From the receipt of inquiries to the reservation of shipping space for the completed engines, the work is carefully coordinated. In the spacious and well-lighted drawing office are produced the many new designs of locomotives, from the largest to the smallest gauge, suitable for whatever duties required. The preparation of detailed drawings is carried out by a competent staff of skilled draftsmen. Original drawings on approval by the chief draftsman are traced on linen by a staff of experienced tracers, and from these tracings, prints are reproduced for use in the various departments of the company. The careful designing of an 800 horsepower diesel-electric locomotive cab and the use of a full-size model ensures that the controls are placed in the best possible position for safety, convenience, and the comfort of the driver. The correct operation of the valve gear in a steam locomotive is of great importance, and this model ensures that the best design is achieved. From the simple beginnings of locomotive history, this company with its design and research staff, together with its well-equipped works, has been able to keep to the forefront in the changing times and conditions of the modern age. The knowledge which has been acquired has been translated in these shops into locomotives which are serving in all parts of the world today. As each new development has taken place, new machines, some designed specially, have been introduced to make the product cheaper and more efficient. New layouts have been adopted, new methods introduced, new materials used, closer working limits specified, all working towards the one end, the production of first-class locomotives. Locomotives which will give service, not only for the immediate future, but throughout the years to come. Locomotives of proved reliability to give long and economical service, however arduous the conditions. making of an axle is a precision operation, and the machining of the journals entails grinding to give the finish and accuracy demanded. Freedom from tool marks is essential for long life, and high surface finish reduces axle box wear and heating when in service. Perfect finish is readily obtained using one of these axle grinding machines of the latest type. The pressing on of wheel centers is a job requiring skill and experience, as only a perfect fit can be allowed. About 10 tons per inch of axle diameter is required to force on the wheel center. The 60-ton tensile rolled steel tires are bored with carbide tools at speeds of up to 500 feet a minute. A modern locomotive may need as many as 26 axle boxes, which may be of plain or roller bearing design for the engine and tender wheels. These requirements can only be met by using the best type of machines, such as this vertical borer, which can easily handle axle boxes of bronze or steel. The fitting of the keeps and liners and the final finishing then becomes a straightforward operation. From wheels and axle boxes, a natural step is to frames, each type having differences in design to meet the requirements of individual railways. Plate and bar frames have been used extensively for many years, and a development embodying many of the advantages of both types can be found in the single one-piece steel casting. A composite form of underframe comprises longitudinals of plate or bar with a cradle casting at the rear end, designed to accommodate a large firebox and trailing truck. In many instances, welding technique has been introduced in the manufacture of frame stretchers and drag boxes. The majority of the world's locomotives, however, used plate or bar frames, which are oxy-cut to profile on multi-head machines. Be it plate or bar, the same high degree of finish is required during manufacture to ensure trouble-free running or in service. To this end, the frames are machined to close limits, and this care is well repaid when, after the fitting of the stretchers and cylinders, the locomotive finally begins to take shape in the erecting shops. Before the final bolts and rivets are driven home, the two frames are checked with a large square to make certain that the position of the axles relative to the frames and cylinders is correct. Finally, after accurate alignment, the frames are again inspected before further assembly is allowed to begin. Although these locomotives are within a few days of completion, their lives began in the pattern shop many months before. Each new engine and tender requires many patterns for the numerous non-ferrous steel and iron castings used in its construction. Many are used in the company's own brass and iron foundries. Cylinder molding in the foundry is a job calling for skill and experience. The careful positioning of the many cores is essential if a perfect casting is to be produced. Cylinder castings are made of refined iron of special analysis to give long life and service. The pouring of the metal at the correct temperature is yet a further operation which must be controlled carefully if castings of the requisite quality and soundness are to be produced. To these molders, it has become a matter of routine, as cylinders are their main specialty. The small amount of dressing required is a tribute to the care taken in the foundry. This new cylinder shop, a fine example of a modern layout, has been re-equipped with the latest types of machines, arranged in such a manner that the work flows readily from one operator to the next. In addition to the manufacture of cylinders and their components, crossheads, pistons, piston valves and slide bars also find a place in the carefully planned production lines. As well as production for the engines under construction, spare parts for the many and varied locomotives in service can be handled simultaneously. These cylinders follow a clearly defined route from the tables, where they are marked off for the initial operations to the final testing. Flange to frame faces are used as datum surfaces for subsequent boring operations, which ensures accuracy, interchangeability, and high productivity. The precision boring of the cylinder barrels and steam chests requires machines of the latest design and with first-class equipment. Special horizontal boring machines, fitted with heavy-duty boring bars and carbide tools, combine ease of setting up with speed of operation. For machining the ports in piston valve liners, this machine was devised in cooperation with the company's engineers. The cutting tool automatically follows the pattern formed by a master template. This milling machine, suitable for negative rate carbide tools, gives a high speed of metal removal. Mechanical handling, so much in evidence in these works, saves both fatigue and manpower. Each class of locomotive requires its own particular design of crosshead, but the machines are able to deal with all the varying types required. After assembling the crosshead to the piston rod, the cutter hole is machined on a duplex slot drilling machine. Every operation is closely inspected, and final fitting operations are reduced to a minimum. Various other details required in the final assembly are also being produced. Rings like these for the piston valves are produced from a special mixture of cylinder quality iron to give long life in service and to be capable of maintaining an effective seal against superheated steam. Cast in barrel form, machined, ground and finally peened to give the necessary degree of spring, the rings must fit the grooves in the head with only a minimum of clearance to avoid wastage of steam, consequent loss of engine power, and increased costs of fuel and operation. Hine steam chest covers call for very specialized machining, especially the slotting for the valve spindle crosshead. In other departments, other details are also being prepared. The vertical boring machine is turning the base of the dome fitted to the top of the boiler. The dome covers the regulator valve, or in some cases the steam collector. Long before the boiler is ready for assembly, however, the various flanged plates for the firebox and smoke box have to be made. These require large cast iron blocks, which the company manufacture for use in the hydraulic flanging presses. A well-finished flanging block is of great importance. Of recent years, the forge has been superseded to some extent by the welding shop. But for coupling and connecting rods, as well as parts of the valve gear, a well-forged article is still specified. After careful heat treatment, the connecting rods are first machined on a large plano milling machine, capable of machining up to 4 at a time. A similar procedure is also followed for coupling rods. Special machines fitted with heavy revolving tables are required for the milling of the ends of the rods. After machining is completed and before erection, connecting and coupling rods are assembled at the fitting benches. Here the bushings, oil cups and pins are fitted, and after final assembly, the many important dimensions are again checked. Only after this rigid inspection are the rods allowed to go to the erecting shop. Simultaneously, the various other parts of the valve gear are nearing completion. Precision grinding is playing an increasingly important part in maintaining the high standard of modern requirements. The grinding of the radial die path of the reversing link is undertaken on this pendulum grinder, which is fitted with a flexible tube connection to the dust extractor. The finished links undergo critical inspection in specially designed fixtures to ensure interchangeability and perfect alignment. Milling machines are used for numerous operations, and the supply and maintenance of the many special cutters is no small problem. Well-equipped tool rooms undertake this work, in addition to supplying the many new gauges, jigs, fixtures, tools and cutters required for each new order for locomotives. From jig borers to millers, only modern machines are in use. New plant is constantly being introduced to meet new problems, and the successful screwing of a taper thread on one end of a boiler stay was solved by the installation of this particular machine. High-speed tooling with almost instantaneous starting and stopping achieves accuracy and economy. Countless details required in locomotive building are produced in the turning shops. As in the other departments, according to the number of articles to be produced, so are the quantities divided into batches of convenient size. This avoids lengthy manufacturing cycles. Studs and bolts are required by the thousand, and these are made on a large battery of single and multi-spindle automatic machines. Once these machines are set, they run for long periods with little attention, except for feeding with new bars and occasional checking to see that the size of the product is within the limits prescribed, both for diameter and thread form. Certain specifications call for forged bolts and pins, and the turning of these provides an interesting example of the use of carbide-tipped negative rake tools. This machine is capable of machining at speeds of over 3,000 revolutions a minute, and with feeds up to 140 cuts an inch. With such a high rate of metal removal, the machine has to be almost entirely enclosed to stop the cuttings flying. The safety of the operator is never sacrificed for high productivity. Steel and copper stays for the firebox call for very special production. To give trouble-free service, the formation of the threaded portion and the pitch of the threads over the entire length must be maintained. This is achieved by using lathes with a master lead screw above the machine, close to the die head. Most of the non-ferrous parts are produced by the company, and a large variety are seen on the benches in the brass finishing shop. Very soon these too will join the engines. For many of the numerous brass screws, pins and pipe fittings, an automatic electric capstan lathe is used. Once the machine is set, the control is almost entirely automatic. The correct feeds and speeds are pre-selected for each operation. The machine slows down for screwing. It reverses and stops itself when the final operation is completed. Not all work, however, is so automatically controlled, and many parts need marking out prior to machining. After machining, certain details go to the fitting shops for finishing, inspection, and building into sub-assemblies. Meantime, the coppersmiths are busy preparing the many copper pipes and making the various moldings used for clothing the boiler. Dome covers are made in two main parts, which are welded together. Afterwards, the joint is carefully dressed and hammered to the true shape, resulting in a perfectly contoured and well-finished cover. Works production, however, can only run smoothly provided it's controlled by an efficient administrative organization. Pre-planning and rate fixing are now essential aids in dealing with the complexities of modern industry. To ensure a steady flow of work through the shops, the Progress Department issue carefully prepared production programs covering the many varied orders on hand. Supplying locomotives of different types simultaneously to all parts of the world has been a long-standing achievement of the company. This control board gives only some small idea of the final destination of the locomotives. The card printing department, from information prepared by the planning and progress departments, prepare and issue the many thousands of printed time cards and process sheets required for each order. The information is punched onto metal plates, which are then used for printing these various documents. Mechanization of accounting has been highly developed, and calculating and punch card machines are here engaged on the preparation of the payroll and other costs. From data condensed into suitable statements and supplied by this department, the management's in a position to control all expenditure and thus ensure economical output. The careful coordination between administration and works results in production lines which are highly flexible to meet all demands, one of which is for boilers. In addition to the boilers required for the engines in the erecting shops, there are many required for spares for those already in service. To fit a new or repaired boiler when the engine is in the railway workshops for a major overhaul considerably reduces the number of days the engine is out of traffic. The secret of the building of a good boiler lies in the preparation of the plates, especially the flange plates. Heated to the correct temperature, the various plates are formed in powerful double-acting hydraulic presses. This door plate, for one of the smaller boilers, is flanged in one operation. After the careful positioning of the plate, the rams of the press are set in motion, and the operation then proceeds normally under the practiced eye of the chief flanger. The boiler barrel is made from rectangular plates, formed to shape in these special plate rolls. Whether for a parallel boiler or a tapered boiler, the procedure is much the same. Each pass through the rolls brings the plate nearer the finished shape. Although many of the plates are drilled in the flat, certain holes have to be drilled on this boiler shell drill after assembly. The boiler barrel is connected to the outer firebox by hot rivets in this special riveting machine. A good joint demands a properly drilled hole and a well-fitted rivet. The hydraulic ram which forms the rivet exerts its pressure until a certain degree of cooling has taken place. This makes for a tight joint. The boilers are riveted in the vertical position in deep pits. the 60 feet overhead cranes being controlled from ground level by the riveting squads. A thorough external and internal examination is made at each stage of assembly of the boiler, and especially before the fitting of the inner firebox. With the finishing of the inner firebox and the fitting of the foundation ring, the boiler nears completion. Reaming and tapping of the many holes for the water space stays is done by portable power-operated machines. After the insertion of the stays, these are riveted over by pneumatic hammers. Finally, with the fitting of the many tubes, the building of the boiler is complete. After thorough hydraulic and steam testing, it's then ready to join the engine. By this time, the frame is ready to receive its boiler, as it's lifted over the other locomotives by one of the powerful overhead cranes. Gently, it's lowered onto the frame, being carefully positioned at the smoke box and firebox ends. Another locomotive begins to take its recognized form. The fitting of the boiler is the signal for many other operations to begin. Within a matter of hours, the smoke box steam pipes are fitted, the cab and reversing gear added, and then the whole engine is carefully lifted and lowered onto its wheels. The valve gear is completed, and there remains only the setting of the valves. This is effected by revolving the driving wheels on power-operated drums in the track. The valve setter, using a remote control switch, rotates the driving wheels and checks the various positions at which they are stopped, with the relative positions of the valves in the cylinder. Before the fitting of the coupling rods, the engine is lifted onto another pit, with the driving wheels resting this time on heavy rollers, also let into the track at rail level. Under the engine's own power, the driving wheels are made to revolve, and the operation of the various parts of the valve gear and reversing gear is checked. Finally, the coupling rods are fitted, and the engine, still under its own steam, leaves the workshop for its last trial run on the test track to allow any brake adjustments to be made. For the 2000th locomotive delivered by the company to South Africa, special nameplates were prepared to mark the occasion. The engine was named Bartholomew Dyers, after the first man to sail round the Cape. In South Africa, Mr. Sauer, the South African Minister of Transport, unveiled the plate on the locomotive. Sir Andrew Duncan, one of the company's directors, formally handed over the locomotive to the South African authorities. Also present were Mr. Larimer, Joint Managing Director, and the Portuguese Ambassador. With the breaking of the tape, as it starts on its first journey towards the Silori Pass, yet another locomotive joins its forerunners in the service of this grand country. British Railways, however, are not being neglected, as more than 350 locomotives have recently been supplied to one of their regions. Finished and painted, number 62063 is ready for the road. Developed from so many different raw materials by the skill of the craftsmen, each one carries the insignia of a good locomotive, the diamond nameplate of the company. This locomotive, like the many others which have left the works under their own steam for service on the main line, has been made from British materials, fashioned by the skill and knowledge of British hands, thoroughly British, and better still, North British. Many engines for abroad, because of the difference in rail gauges or lack of unloading facilities, can't be delivered as complete locomotives, but can only be handled in a dismantled condition. This tank locomotive is one of these, and after undergoing steaming trials, it's carefully taken to pieces and packed into crates, which can be easily handled at the docks. Coated with protective grease, the side tanks are gently lowered into their individual packing cases, the greatest care being taken to avoid damage to the newly painted surfaces. Packing too is a job where experience tells, experience acquired over many years. Smaller parts also receive the same meticulous care and attention. Each case is designed for a specific number of articles, and each part fits into position like the pieces of a jigsaw puzzle. Larger parts travel uncrated, protection being afforded to machine surfaces. This cast steel locomotive frame has a length greater than the entrance to the ship's hold, and of necessity is slung at an angle. Handled by a floating crane, it is carefully guided into place to be securely lashed for safe stowage. With few exceptions, no steam engine can be called complete without its tender. And here on the assembly lines in the tank shop, the riveted and welded tanks are nearing completion. Whether the orthodox rectangular tank, or the cylindrical tank, or the newly developed light alloy tank, the same care and attention is given to them as to the locomotives. In the tender shop, the frames are prepared, ready to receive the tanks, which are placed into position by overhead cranes. After wheeling, the tender is ready to join the engine, or to be transported as a unit on a road vehicle direct to the docks. To see a fully completed locomotive being handled for shipment is, to those unaccustomed to it, a most impressive sight. Brought from the test track over the tops of the other locomotives undergoing assembly, the crane gently lowers it onto the waiting vehicle. Before the lifting tackle is finally removed, the wheels are securely wedged to prevent movement during transit. All bright parts have received a coating of anti-corrosive grease, and the chimney covered by protective material. Paintwork is similarly treated to resist the ravages of the sea air. With every precaution taken and suffering the indignity of not being able to go under its own steam, this particular locomotive starts its long journey to Nyasaland. Preceded by a motorcycle police escort, the convoy is always a source of wonder to passers-by. Towering above most other vehicles and bearing a cold aloofness to traffic signals, the locomotive draws nearer to the docks. The Clan Campbell is waiting to receive it at the quayside, conveniently berthed under the most powerful crane on the Clyde. The first stage of the journey is almost over, and with its fellows already en route to the ship, it will be carefully lifted on board. A consignment of tenders has already arrived and loading begun. After the tenders, the engines. And using the company's own specially designed lifting gear, the work goes smoothly on. With only inches to spare, the locomotives are lowered into the hold, there to be carefully stowed for the long journey abroad. As the last hawser is cast off and the tugs take charge, yet another consignment of locomotives leaves for overseas. Today, Nyasaland, yesterday and tomorrow to the far corners of the earth, to the 5 continents of the world, to the dominions and colonies. North British locomotives have left the Clyde to give long and faithful service. Locomotives which, whatever the climate and however adverse the conditions, have given of their best, the best there is in locomotive building, North British.